Okay, so here we go. Number 31, you had a problem, and it was talking about a TV, and they talk about it's called the aspect ratio of a television is 3 to 4, which means that as they make them, they measure a television by its diagonal, and the diagonal is always kind of part of a right triangle where the dimensions, the length and the width of the TV screen are in a ratio of 3 to 4. And so they kind of drew this trying to give you a hint here. Now, there's a couple of ways to do this. I'm going to do the way most of you chose to do it first, okay, because you just had some issues with some algebra here that I wanted to talk about. There's a faster way to do it, and we'll look at that first, but I want to kind of go where your brains went, okay? If I'm trying to find the diagonal here, it says represent the dimensions of the screen as 4x times 3x, and they drew that picture for us, so that they're actually talking about the figure. And the length of the diagonal is d. It says write an equation for d in terms of x. That means they want me to write an equation which says d equal blah, blah, blah with x's in it. Now, the longer way to do this involved the Pythagorean theorem, and it's perfectly fine to do it this way. It's where most of you tried to go with it. If I do the Pythagorean theorem, I could say a squared plus b squared is c squared, on a right triangle. That would be, here my legs of my triangle would be 3x and 4x, and my hypotenuse would be d, okay? Now, if I wanted to say, d squared equal 3x squared plus 4x squared, I'll write my answer up there in a minute where I put my d equal. If I wanted to do that, here's where a lot of you went a little wrong here. When you square 3x, you get not 3x squared, you get 9x squared. Remember, you have to square both parts. And this caused a lot of you to get kind of off, and that caused problems. When you square 4x squared, that's 4x times 4x. Wouldn't that be 16x squared, right? So d squared would be 9x squared plus 16x squared is 25x squared. And if I want to solve for d, I could square root both sides. And the square root of 25 is 5, and the square root of x squared is x. That's one of the ways you could have come up with your equation. Your equation is d equal 5x. There was a faster way. The faster way is to remember our Pythagorean triples. Remember, that was in this section. So they were kind of thinking maybe you'd do that, but it was kind of, most of you thought about the Pythagorean theorem, and that's fine because that's another way to do it. Wish I had drawn the triangle the other way. Okay, so I'm taking this triangle, I just flipped it around, so this will be 3x and 4x. Do you remember how, 45, how about 4x? Do you remember if we had that Pythagorean triple, a 3, 4, 5? Isn't this a 3, 4, 5? But instead of multiplying through by number like 2 or 3, didn't they just multiply through by x? So I could have said, oh, well, what is this diagonal d here? Oh, it's just 5x. I could have used that idea of the triple 3, 4, 5 to figure out that was 5x. So there's two ways to do that, and most of you chose to try it through the Pythagorean theorem, which is great because it means you were applying things that you learned before, right? But you can see that other way might have been a little faster, right? Okay. So now what 32 said was to write, I wrote it up there on the board, x in terms of d. That means take that equation that you just got and solve it for x. When you see x in terms of something, that means solve for x. If I saw the above, it said in the above equation, number 31, it said d in terms of x. It means I wanted d by itself, and then the x is on the other side. Now I want x by itself, and the d is on the other side. And remember, in this book, doesn't he take you through a process, usually trying to get you to the answer? So if I'm solving for x, all I got to do is divide both sides by 5, and I get x equal d over 5. Most of the time we probably would rather write it this way. If I saw this appear on your paper and I didn't see any work, I counted it wrong because I need to see your work, and I know like this one was in the back of the book, some of these were. I needed to know where you got it, okay? And usually that just didn't pop in your head. You at least would have had to do something like that. And most of the times when people were on the right track, they had work there that I could grade. So again, you're showing your work as often as possible. Okay. Now 33 said this. It said, okay, you got all this stuff. We just did all this stuff, right? What if the diagonal of this television, we'll call it D for diagonal since that's what they called it, is 14? And it says, if the diagonal is 14 inches, what are the corresponding dimensions of the screen? Well, if the diagonal over here is what we found out early, wasn't it 5x, right? So how am I supposed to do this? I know that in problem 31, I figured out that the diagonal was 5x. So if I'd labeled it on the figure, I'll put 5x. If I'd labeled it on the figure, it might have helped me with this one right here. And again, you're trying to figure this stuff out. That's the way this book is, which is, hard for some people. And it's one of the reasons why it's not just so straightforward as doing a worksheet a lot of times when we're doing this. Well, if the diagonal is 14, isn't the diagonal also 5x? The problem is they want me to tell the dimensions, and the dimensions are, let me put my answers in a box over here, they are 3x and 4x. In order to tell the dimensions, don't I need to know what x is? Right? Well, how am I going to find x? Well, if the hypotenuse or the diagonal of that TV is 5x, and I also know it's 14, I could figure out what x is just by solving this teeny little equation here. I could divide both sides by 5. And if I divide that out, we'll go ahead and write it as a decimal just to make this go a little faster. I think it's 2.8. So x is 2.8. I can figure that out, and they kind of was trying to take me through that by walking me through, okay, we could figure out that side of the right triangle. I could solve it for x and 32, and then I could plug D in for x. It's kind of what he was trying to take you through here. And we could find out x is 2.8. Well, they want the dimensions. That means they want the length and the width. They're looking for these two things right here, the length and the width, those sides of that right triangle. So what I could do now is I could plug that in. If the height is 3 times x, well, that's just going to be 3 times 2.8, which is, I believe that's 8.4 if I'm doing that correctly in my head. And 4x would be 4 times 2.8, and that would be 11.2. So basically what this collection of problems was is they're giving you a right triangle, and he was trying to help you. I'm not sure if it helped or hurt, but he was trying to help you see how you could kind of arrive at a way to figure this out. You could have said, you could have done some other things here. You could have drawn similar triangles and figured out the diagonals. By drawing the 3, 4, 5, and then, saying, well, I know my hypotenuse is 14, so I could have solved it just by drawing similar triangles, but he was trying to take you through how could you do it with an equation.